Description.
Alright, good afternoon, ladies and gents. Lesson 131, we're still doing tutorial 3. We are now going to go to question 11. Yesterday we did question 9, CD, part C and part D, and we did question 10. Now we're going to question 11. Alright, so question 11 says, without solving, write down the sums and products of the roots of the following equations. Without solving, write down the sums and products of the roots of the following equation. Okay, so meaning it's very possible for us to find the sum and the products without really solving. Okay, so take note of what the question asks you for. Basically speaking, we'll start from here. Now, yesterday you were told to say any quadratic equation can be written as x squared minus the sum of the roots plus the product of the roots. Okay, so from this equation we say the sum of the roots is found as negative b over a, and the product of the roots is given as c over a. Right, so we have got a question, part A, which says x squared minus 3x plus 5 is equals to 0. So what I need to do is I need to identify my a from here. So a is 1, b is negative 3, and c, the constant, is 5. So what is the sum? The sum is alpha plus beta, which is negative b over a from here. Now we know what b is. It's negative 3. So negative 3, what is a? A is 1. So this ends up just being positive 3. And the product will be c over a, so that is just 5 over 1, which is 5. End of that question. Okay, so we're saying for you to find the product and the sum, what you need is, you need to have the basic understanding that the formula for the sum of roots is negative b over a, and the product of roots is c over a. Then from this formula you need to identify a, b, and c. Alright, so to find the sum, I said the sum is negative b over a, so what was b in this case? Negative 3. So we said negative 3, but there's a negative outside the b, so I put the negative over 1, which is equals to 3. Then we have the product, which is alpha times beta is equals to c over a, and the product is found as 5 over 1, which is just 5. Okay, so that ends that question. Let's look at another one. The other one says 2x squared plus 7x is equals to 3, right? So before I can even write this question, I need to reorder it or rearrange it into its standard form. So what's the standard form? We need everything to be on one side, so we have minus 3 is equals to 0. So from this, what is a? A is 2, b is 7, and c is negative 3. So meaning the sum of these roots is found as negative b over a, so we have negative 7 over 2, and the product of the roots will be c over a, so we have negative 3 over 2. So that's your answer. Okay. So we're saying to find the sum of the roots, what you need to do is you need to find the product, identify what your a, your b, and your c is from a given quadratic equation. Okay, it is as straightforward as that. So in this case, we identified that our a was 2, our b was 7. Now the c, we needed these three to to actually be at the same side with the others. So I introduced -3 on both sides. So this is why you see this one ends up being 0, called the inverse of the 3. Okay, so this is how we got to this part. Then from this part, I have to identify A is 2, B is 7, and C is -3. Then now we need the sum of the roots. Alpha plus beta is equal to -7 over 2 from the formula here. So the formula is saying -b over A. So what is B? B is actually 7. And what is A? A is 2. Okay, then -7 over 2 is the sum. The product will now be C over A. So what is C? C is -3. And what is A? 2. So alpha times beta, this is the product, this is beta, is equal to -3 over 2. Okay? All right. Let's go to question 12. Question 12 says the roots of the equation 2x squared. Alright, so maybe before we go to question 12, let's go to question 12, let me write it. We're talking about 2x squared is equal to 6x minus 9. Right? So as I said, we need to rearrange this to ensure that it's in the form of the standard equation. So this is 2x squared minus 6x plus 9 is equal to 0. Okay? Now, whenever you are faced with questions to do with the roots of a quadratic equation, you always have to first find the sum and the product. Okay, it's very important. Whenever you have questions to do with the roots of a quadratic equation, you need to find the product and the sum. So in this case, what is our sum? Our sum from this question is -b over A. So what is B? So if you identify here, our B is -6, so we have -6 over 2, alright, which is just 3. Then our product is equal to C over A. So what is C? C is 9. What is A? A is 2. So 9 over 2. Alright, so we're saying in order for us to do this question, the first thing that we need to know what the sum is and what the product is. So from the previous question, it's the same type of procedure that we used on the previous question. That's the same procedure that we're going to use on this question. So we're saying that we have to identify A, B, and C. So A is 2, B is -6, and C is 9. So the sum is -6 over 2, which is +3. And then we have C is 9 and A is 2, so product is 9 over 2. Okay, so it's very important because I need to use those in order for me to solve the rest of the questions. So 9 over 2, so I'll put them here. So we say the sum is 3, and we have a product as 9 over 2. Okay, I'll keep making reference to those two. We have 2 and 9 over 2, so I'll keep making reference to the same. Okay, so what do we do now? The first question A is saying find the values. So we're looking for the values. Plus alpha squared beta cubed. Okay, so if you look at this question, it looks complicated, but really it's not. Okay, it's not as complicated as it looks. Because if you really analyze the question, you will notice that from here we have things that are common. Okay. For instance, you know there's alpha cubed and there's alpha squared there. There's beta squared and there's beta cubed. So what is common? We have alpha, which is common to both. So now there are 3 here, but there are 2 here. So you can factor out 2 of them. Okay, so alpha squared is common. Now if I factor out alpha squared, what else is common? We have 2 betas here, we have 3. So even beta squared is also common. So if I factor out alpha squared from here, what remains? We have alpha because we removed 2, there are 3. If I factor out beta squared from here, what remains? 1. So this is just alpha times 1 plus. From here, I'm going to factor out alpha squared, which is here, so it's 1. If I factor out beta squared from here, there are 3 of them, so 1 of them will remain. Okay? So that's just factoring out. Now, this can be written as alpha beta squared. Remember that I can distribute this square provided it is it's multiplication or division. You cannot distribute the power if you are dealing with addition or subtraction. You can only distribute the power if you are dealing with multiplication or division. Okay, so we're saying this is alpha beta squared. Then from here, what we're going to do now is we're simply going to replace. Okay, so do we know what the product is? Yes, the product is 9 over 2. From here. Do we know what the sum is? The sum is 3. So now we have 81 over 2 multiplied by 3. 9 times 9 is 81 and 2 times 2 is supposed to be 4. Alright, then we are looking for 81 multiplied by 4. Sorry, multiplied by 3. So this is 324. So that's basically 243. So this is equals to 243 over 4. Okay, so that's 243 over 4. You write it nicely. So what did we do? We said whenever you're dealing with such questions, just look for what's common, then we factored out alpha squared, beta squared. So this is where we got to. So after simplifying, we know alpha times beta is 9 over 2, and we know alpha plus beta is 3. So I placed 3 here. 9 over 2, 9 times 9 is 81, 2 times 2 is 4, 3 times 81 is this one I did here, so this is 3, that's 24, so 243, so it's 243 over 4. That is your final answer. Alright, let's look at a different question. The other one says alpha squared plus beta squared. Okay, so now we have a standard for this. The standard for alpha squared plus beta squared is given as alpha plus beta squared minus 2 alpha beta. Okay, so this is standard, know it as you see it. Okay, we don't have to go into deriving. This is not the session for that. So whenever you see alpha squared plus beta squared, remember that you need to replace with alpha plus beta squared minus 2 alpha beta. Okay, so this is how we always deal with these things. Every time, this is a standard. Remember, standard is something that you can always rely on. Okay, so we're saying, do we know what alpha plus beta is? Yes, it's what? 3 then squared minus 2. Alpha times beta is 9 over 2. From here we have 9, this and this will cancel, minus 9. Well, the answer is 0. Okay, so that is your final answer. So I'm saying this is standard. Okay, so we use it as a standard formula like that. Now, it will not always be the case that this question will come straightforward like this. This standard here can actually come from some fraction, which we will later see. Then you just have to remember that you have to replace the standard value there. Okay, so we'll say 9 minus 9 is 0, so that is that. Okay, let's look at a different question. Okay, so let's look at this. 1 over alpha squared plus 1 plus 1 over beta squared plus 1. Right, so what's the common denominator here? The first thing that we need to find here is the common denominator. So what is the common denominator there? The common denominator is simply alpha squared plus 1 beta squared plus 1. Okay, so we have alpha squared plus 1 multiplied by beta squared plus 1. Right, so this alpha squared plus 1 into this is 1, this beta squared plus 1 multiplied by 1, beta squared plus 1, plus this into that is 1, alpha squared times this, that's alpha squared plus 1. Now, whenever you have such questions and you are simplifying, please take it to something that you know, alright? So try to write this in the form that you are familiar with. That's how we work with these things. Okay, so take it into the form that you're a bit familiar with. So what is common? You will notice that from the previous question that we are just from doing, we looked at the question that was talking about alpha plus beta squared. So I'll collect these two together. Then 1 plus 1 is 2. Right, then now I need to expand this. So expanding the denominator, we have alpha squared times beta squared. This is alpha squared, beta squared. This times this, that's plus alpha squared plus beta squared. 1 times 1, 1. So I'll repeat that. We're saying alpha squared times beta squared, alpha squared, beta squared, alpha squared times 1, alpha squared, 1 times beta squared, 1 times 1, 1. Okay, so that is that. We are done with that. But of course, that's not our final part. So where next do we go to? Alright, so now we need to reintroduce. Now, remember that we know what this is, and we know the standard for this, okay? So whatever I've put in brackets, you know the standard. I've changed the color of the marker that I'm using. So we are saying, we know that alpha squared plus beta squared is simply alpha plus beta squared minus 2 alpha beta. Okay? Then plus 2, everything over alpha squared beta squared plus open brackets alpha plus beta squared minus 2 alpha beta. This is the part I've written here, then plus 1. Okay, now we need to replace. So what is alpha plus beta? This is 3 squared minus 2, 9 over 2 plus 2 over 9 over 2 squared plus 3 squared minus 2, 9 over 2 plus 1. Okay, so we now have this and this. So that's 9 over 9. And I've actually, since I'm doing the same question, I know this is actually 0, but I will not replace it as such. So 9 minus 9. So I'm saying, from the previous question, we know this we found as 0, so I can place 0 here. From the previous question, then plus 2 over. This again is 0 from the previous question, so we have this as 81 over 4 plus 1, okay, which ends up being 2 over, now we know 81 over 4 plus 1, this is the same as 85 over 4. So if you say the common denominator here, the common denominator is 4. So let's write it from this end. So we have 2 divided by 81 over 4 plus 1. Okay, so common denominator here is 4. 81 plus 4. Then here we have 2 divided by 85 over 4. Now we know that from your previous knowledge, division changes to what? Multiplication. So this is the same as 2 times 4 over 85, okay, which is just 8 over 85. So I'm saying from your previous knowledge, we know that division changes to multiplication, then whatever is on the right flips. So this one has flipped, the 4 is now in the numerator and the 85 is now in the denominator. Then now I'm multiplying 2 times 4 over 85, which is just 8 over 85. So the final answer is 8 over 85. Still doing questions on that, so we see the sum is 3 and the product is 9 over 2. Okay, so we have this one, alpha cubed plus beta cubed. So we have a standard formula for this as well. And that standard formula is alpha plus beta cubed minus 3 alpha beta, alpha plus beta. For you people who love to master formulas, how do you master such a formula? Okay, know that since you're dealing with cubed, it's the sum cubed, okay, minus 3, instead cubed 3. Then the product alpha times beta, what is here is always the sum. Please, in case you forget, 3 alpha beta is multiplied by the sum. Okay, so we know what alpha plus beta is. Alpha plus beta is 3, cubed minus 3, product is 9 over 2, sum is 3. Okay, so I'm saying alpha plus beta is 3, cubed minus 3, alpha times beta is 9 over 2, then alpha plus beta is 3. So here we have 27 minus 3 times 9, which is again 27, over 2 multiplied by 3. Now we know this is actually 81, so let me write this as 81. 3 times 3 is 9, 9 times 9 is 81, so 81 over 2. Okay. So common denominator there, we have 2, then 1 into 2 is 2, 2 times 27 is 54, okay, minus 81, because 2 into 2 is 1, 1 times it, 1 is that. Okay, so what's 81 minus 54? Just for better views, I know that the final answer will be negative because it's the 81 with the negative. Okay, so we have 7 there, 1, 11 minus 4, that's 7, then 7 minus 5, that's 2. So we have 27. But as I said before, because you are doing the negative, this is negative 27 over 2. So we're saying from here, we are looking for the common denominator. The common denominator there is 2. Then 1 into 2 is 2. 2 times that is 54 minus 81. 54 minus 81 is what I was solving here. Negative 27 then over 2. Okay, so that's how you go about that question. Question 13. Question 13. Alright, so question 13 says, let alpha and beta be roots of the equation m minus 3x minus 2x squared is equal to 0. Okay, so you've been given that equation and the question has not been stated, so let's look at what the question is. Find in terms of m an equation whose roots are alpha squared plus 1 and beta squared plus 1. Okay, so we're looking, find in terms of m an equation whose roots, so we've been given that the roots in question are alpha plus 1. Okay, and beta squared plus 1. Now, they told us to find in terms of m. Okay, now, one thing we should know is we have to rewrite this in standard form. This is 2x squared minus 3x plus what? M, because m is the constant, it's equal to 0. Alright, so from this, what is the sum? As I said, whenever you're dealing with a question to do with roots, what you need to first find is the sum and the product of the roots. So, what is the sum and what is the product of the roots in question? So, in this case, the sum of the roots alpha plus beta is given as negative b over a. So, what is b in this case? B is negative 3. So, you have negative 3 because of the negative again. What is a? Negative 2. Okay, so b is negative 3. So, negative 3 over a is negative 2. So, you have this as positive 3 over 2, which ends up becoming negative 3 over 2. Okay, then you have the product of the roots, which is c over a. What is c? C is m. What is a? A is 2. So you have that. Okay, so we're looking for the equation whose roots are those in terms of m. Next up, what we're now going to do is, remember what I said. I said any quadratic equation can be written as x squared minus sum of roots x plus product of roots. Okay, so that's the standard formula. Any quadratic equation can be written as x squared minus sum of roots x plus product of roots. Okay, so from this, that's what we're going to now derive. What are the roots in question? So the roots are no longer alpha and beta, but these two which we've been given. So I'm marking it star. Okay, so the roots in question are the ones that are marked star. Okay, so you have x squared minus the sum of the roots in question. What are the roots? Alpha squared plus 1. Then I'm going to add plus. The other root is beta squared plus 1. Okay? Then plus x plus the product of the roots. Which ones? The same ones. So the roots are alpha squared plus 1 multiplied by beta squared plus 1. So that's the formula that we're going to use. From here, we're going to say okay, so we need to find the sum and the product. So what is the sum here? So this can be written as x squared minus alpha. Remember, it's just like removing the brackets alpha and alpha. So I want to write it as alpha plus beta squared. Then 1 plus 1 is 2. X, then plus the product. So the product alpha times this is alpha squared, beta squared. Alpha squared times 1, alpha squared, 1 times beta, beta squared, 1 times 1, 1. Okay, now remember we said we know the standard for this. So what's the standard for this? The standard for this is alpha plus beta squared minus 2 alpha beta, this part here, then plus then 2 here, then OX. Okay? Then plus, this one will be written as alpha beta squared plus, we're going to write this in standard form as well. So I'm going to write this one in standard form as well. So it's going to be alpha squared plus beta, alpha plus beta squared minus 2 alpha beta, then plus 1. Okay, so that's the product. So now the equation in question is x squared minus, we have to replace alpha plus beta. What is alpha plus beta? It's negative 3 over 2. So alpha plus beta is negative 3 over 2, so we have negative 3 over 2. So we'll say negative 3 over 2 squared from here minus 2 m over 2, okay, plus 2. So this is just the sum part I'm doing. So we have x squared minus, remember this is just the sum part I'm doing, the board is not enough. I think now I can hear. Okay, the board is not enough, so let's just do the sum. Here is, I'll write it here for reference. So we're saying alpha plus beta is negative 3 over 2. Alpha beta is m over 2. Okay. X plus the product m over 2 squared, we're here now, plus the sum, negative 3 over 2 squared minus 2, the product m over 2 plus 1. Okay, so if you are checking what we're doing, we're saying we started with x squared, then minus, that's the minus here, We replaced alpha plus beta, we know it's negative 3 over 2, so that's the negative 3 over 2 squared minus 2 alpha times beta, which is m over 2. Alpha times beta is m over 2. Then plus 2, these two here. Close x, then plus. We're now looking at this other part here. So that part we're saying is the product is alpha times beta squared. So we have m over 2 squared, then plus the sum. What is the sum? The sum is negative 3 over 2, then squared right here. Then from there, we have minus 2 m over 2, because that's the product, and plus 1, right? Then evaluating this, we have 9 over 4 minus this and this will cancel, so m plus 2 x plus m squared over 4 plus 9 over 4 minus m plus 1. So now we know 9. What is 9 over 4 plus 2? This is actually the same as 17 over 4. Okay. Minus m. Then we have x plus 9 over 4 plus 1. Okay, so that is 13 over 4. So we have 13 over 4 plus m squared over 4 minus m. So I'm saying here I simply added 9 over 2 plus 9 over 4 plus 2, which is the same as 4 times this, 8 plus 9, 17 over 4 minus m, x plus m squared. So the m squared is the one I've written here. 9 over 4 plus 1. This is the same as 4 plus 9, which is 13 over 4. Okay, then 13 over 4 plus m squared minus m. Okay, so now we can actually write that. We can finish that up. So this is the equation in question. Okay. Now we can go a step further if we want to write, simplify it further. So we can actually say 4 times m is 4m. So this is the same as 17 minus 4m over 4 x, then plus common denominator here is like 4. So we have 4, right? Then we have m squared minus. So I'm just writing, so 4 into this, or let's write the way it is. So 4 into 4 is 1 times that, that's 13. 4 into 4, 1 times that, that's m squared. 1 into this minus m. Okay. Finally, the answer ends up being 17 over 4 x plus m squared minus m plus 13 over 4 as our final answer. So that's the equation that we have been asked for. Note, I've just rearranged. I've started with the highest powered variable, m squared, then followed by the second highest powered variable, which is minus m, then written the constant at the far ends. This is 13, though it looks like a 15, but it's a 13. Okay, so that's your final answer. Alright, so find in terms of m an equation whose roots are alpha squared plus. So that result, okay. Okay, so I'll write my result here for reference. Okay, so the next question on that says, if alpha minus beta, meaning the difference, is 9 over 2, find the value of m. So we've been told that if the difference of the two roots is equals to 9 over 2, find the value of m. How do we find the value of m in that case? So we need to remember that alpha minus beta is actually root, standard, alpha plus beta, squared minus 4, alpha beta. Okay, so, but we know alpha minus beta is 9 over 2. Do you know what the sum is? Yes, we found the sum as negative 3 over 2, then we're squaring, minus 4, the product was m over 2. Okay, it's the same question. So we're saying, I'm replacing, alright, the sum here. We found the sum as negative 3 over 2, and the product was 9 over m over 2. So I'm going to use these two results in order for me to find my answer. Okay, so this is basically now going to be equal to 9 over 2, 9 over 4, 3 times 3 is 3, so we have 9 over 4, minus this and this will cancel, so this is the same as 2m. Right, so 2 into 2, 1, 2 into 4 is 2, that's that. Alright, so I now want to get rid of, we can actually form this into something as a single fraction, so we have 9 over 2 is equals to root of 9 minus 4m, sorry, not 4, 8m over 4. Okay, so common denominator here is 4, 4 into 4 is 4, times 1, 9 minus 1 into 4, 4 times 2m is 8m. Okay, now we want to solve for m, so we want to get rid of the square root, so we square both sides. Okay, doing that, we now have 81 over 4 is equals to 9 over 8m over 4. Okay, so I want to get rid of the 4, so I'll multiply throughout by 4. We have 81 is equals to 9 minus 8m. Okay, so now we have negative 8m is equals to 81 minus 9. Because when the 9 goes the other side, so we have negative 8m being is equal to 72. Okay, over negative 8 over negative 8. Remember, 8 times 8 is what? 72. So this is, 8 times 9. So meaning this is simply negative 9. That's your m. That is your m. is your m. So that ends question 13. So we said we simply wanted to get rid of the 4, so I multiplied throughout by 4. So this 4 and this 4 cancel. That's how we came to 8(1) is equals to 9 minus 8m. Then the 9 went the other side, negative 8m is equals to 8(1) minus 9. Then 8(1) minus 9 is 72. Then I divided throughout by 8 because I wanted n, and the answer ends up being negative 9. Right? Alright, so what if we were asked to find the resulting equation after that? Alright, so it wouldn't be so complicated, would it? If you just replace negative 9 here, there. Right? Question 14. Question 14 says the roots of 2x, so we have 2x squared is equals to 3x plus 6 are alpha and beta. Find the equations whose roots. Okay, so now we've been given this quadratic equation. First thing, we're going to write it in standard form. Okay, so now our a here, you know our a is 2b, that's c. So what's the sum? So as I said, whenever you're given such a question, the first thing you need to find is the sum and the product of the roots. So the sum of the roots, in this case, we have negative b over a. Okay, what is b? B is negative 3, so negative 3 over a, which is 2. So the answer is just 3 over 2. The product of the roots is c over a. C is negative 6 over a is 2, so the answer is negative 3. Okay? So, part A. Part A. So let's start from B instead. 1 over beta and 1 over beta. 1 over alpha and 1 over beta. Alright, so you've been given this quadratic equation here. Then from this quadratic equation we've derived the sum of the roots is 3 over 2 and the product of the roots is negative 3. Then you've been asked to find the equation whose roots is this. So we'll say, remember x squared minus sum of roots x plus product of roots. Okay, so in this case, what are the roots in question? The roots in question are 1 over alpha and 1 over beta. So adding them is 1 over alpha plus 1 over beta, x plus the product of the two roots 1 over alpha multiplied by 1 over beta. Okay, so we have x squared minus common denominator there. So we're saying in order for us to find the quadratic equation, we need the sum of the roots and the product of the roots. Okay, so to find the sum of the roots and the product of the roots, what I said is you need to use the formula negative b over a. Okay, and the product, the sum is negative b over a and the product is c over a. So from the given quadratic equation here, we found the sum as 3 over 2 and the product as negative 3. Okay, so now that we know the sum and the product, you've been now asked a new question. What are the equations of the equations whose roots are 1 over alpha and 1 over beta? So now we know that every quadratic equation can be written in the form of x squared minus sum of roots x plus product of roots. Okay, so what are the roots in question? The roots is 1 over alpha and 1 over beta. So what's that quadratic equation? So we need to find the sum. 1 over alpha plus 1 over beta x, that's the sum. Then the product of the two roots are 1 over, or is 1 over alpha multiplied by 1 over beta. Okay, so write it here. So what's our self sum? We're dealing with the sum. So 1 over alpha plus 1 over beta. Common denominator here is what? Alpha times beta. Okay, alpha into alpha, that's beta plus alpha. So alpha into alpha is alpha, beta times 1, beta. Beta into beta is 1, alpha times 1, that's alpha, okay? So now we know that alpha, beta plus alpha is the same as alpha plus beta by the law of commutativity. So, by the commutative law. So now, we know what alpha plus beta is. What did we find? 3 over 2. Divided by the product of the roots, which is what? Negative 3. Okay, so negative 3. So we know that this will change to multiplication. The other one will flip, negative 1 over 3. So this and this will cancel, so negative 1 over 2. Okay, so this is the sum of the roots. Okay, next, what we need is the product of these roots. What we need next is the product of the two roots. Okay? So how do we find the product of the two roots? So to find the product of the two roots, we're going to say one over alpha multiplied by 1 over beta. So 1 times 1, because those are the roots, these ones there. Okay, so 1 over alpha times what? Beta. But do you know what alpha times beta is? Yes, it's negative 3. So this is just negative 1 over 3. Okay, so the quadratic equation we are looking for is therefore x squared minus the sum of the roots which is negative half x plus the product of the roots negative 1 over 3. Okay, so we have x squared plus 1 over 2x then minus 1 over 3. It's equals to 0. So that is the equation that you have been asked for. That is the equation that you are being asked for. Okay, so let's look at this a different question. So you have alpha minus beta multiplied by beta minus alpha. Of course, to find the product, so we need the sum of the roots. Okay. Okay, so this is and beta minus alpha. Okay, so the sum of the roots will have alpha minus beta plus beta minus alpha. If you add these two, you actually notice that this and this will cancel. This will also cancel, so the answer is what? 0. So the sum is 0. Product. Remember, I'm just adding these two roots. Okay, we're still on basically the same question. Alright? But don't forget what's from the very question that we are doing. We say that our sum from the equation that was given was negative 3 over 2. Which was actually positive 3 over 2. And our product was negative 3. Okay, so from here, product we're multiplying alpha minus beta, beta minus alpha. Alpha times beta is alpha beta. Alpha that's alpha squared. Beta times this minus beta squared. This times this. Okay, that's plus alpha beta. Right? So, one thing that we now have to consider is alpha plus beta. Alpha times beta, alpha times beta is common. So, we have, I can factor out the negative, alpha squared plus beta squared plus 2 alpha beta. Okay? This we know is a standard formula for this. Okay? From this part. Then I'm going to say plus 2 alpha beta, the one which is outside here. So this one is standard for this. Then if I remove the square brackets, if you are seeing that, you are going to have negative alpha plus beta squared plus 4 alpha 2 alpha beta plus 2 alpha beta. Okay? So I'm saying this one is standard. Now notice that I took note of the negative. So this is negative is affecting both this and that. Okay, so we have negative alpha plus beta squared plus 4 alpha beta. Alright? But we know alpha plus beta. We know that alpha plus beta is 3 over 2, so we have negative 3 over 2 squared plus 4, the product is negative 3. So now we have this is negative 9 over 4 minus 12. Okay, so this is now negative 9 minus 32 over 4. Which we know that this is going to be basically 41. Yes, 41. So negative 41 over 4. So that is the product of these roots. So the quadratic equation in question is now x squared minus what's the sum of the roots? The sum of the roots was 0, so you don't write it. Oh, maybe. For the sake of summers, 0x product minus 41 over 4 equals to 0. So the quadratic equation is x squared minus 41 over 4 is equals to 0. Okay? So basically that is the final answer that we have. That is the final answer we have. Question 15 is the same question, it's a similar question to what we did in question 9. So question 15 refer to question 9. Okay? Question 15 refer to question 9. So I'll just give you pointers. So find the roots of each quadratic equation subject to the given conditions. The first part A says has equal roots. If the roots are equal, what does that mean? It means that if you have the first root as alpha, the next root will still be alpha. Okay, they are equal. Or if you choose to say the first root will be beta, the next root will be beta. So that's the condition. Okay. Then we have just that. Okay, just that. So you are told that x plus k squared is equals to 2 minus 3k. Okay? So as usual, remember we're supposed to first expand this because we don't know what our a and our b is. So this is x squared plus xk plus xk plus k squared is equals to 2 minus 3k. Then we have x squared plus 2 xk plus k squared is equals to 2 minus 3k. Then we have x squared plus, if these guys go the other side, so you actually notice that we have 2xk plus k squared plus 3k plus 2. Okay, so that's the general expansion. So here, A is 1, B is 2k, and C is everything here, k squared plus 3k plus 2. Okay, so that is our C. Then you've been told that this quadratic equation has got the sum, the roots which are equal. So if the first root is alpha, then the next root will also be alpha. So the sum of the roots will be alpha plus alpha, which is negative b over a. So we have 2 alpha is equals to negative b over a. Okay, but we know what b is, negative 2k. A is what? 1, so it's just negative 2k. Then the product is alpha squared because it's alpha times alpha. Then this is c over a. Then we have alpha squared is equals to c is everything here. So it's k squared plus 3k plus 2, then over 1. So alpha squared is equals to k squared plus 3k plus 2. Okay? So you have 2 simultaneous equations which you need to solve simultaneously. Alright, so that having been said, this marks the end of our tutorial, right? So go and finish up this. So these are 2 simultaneous equations. This one is your equation 1, and this one is your equation 2. Okay, so just replace, remember this is 2 alpha. That's 2 alpha is equals to negative 2k. So if you want, you can say alpha is actually equals to negative k as the equation 1. Okay, then you can replace negative k where there's alpha here to solve them simultaneously. Have a good day. Remember, those who subscribe will actually get live notifications. Whenever we are live, it will notify you. Alright? End of tutorial.